So everything around AI is GPT this, GPT that. It's fascinating, but surprisingly, people have become numb to it, which kind of is mind blowing because for me to build my own GPT takes a lot of work, a lot of education, and is still incredibly fascinating to build something like that. But let's talk about something else in artificial intelligence, something that is actually saving lives. And it's this tool called Maya by a company called Kieran Medical Technologies. And what I spotted was this article by BBC that says NHS AI test spots tiny cancers missed by doctors. And if you're listening, there's a image of a mammogram scan and there's two circles. And this is just kind of an example of how computer vision is utilized to identify the harmful things that could be going on that is undetectable perhaps by the human eye. And by all accounts, anyone involved is very competent. These radiologists, they are day in, day out, but humans aren't perfect. And we build these AI tools to be amazing sidekicks for us. And in this instance, the first in bold thing it says is an AI tool tested by the NHS successfully identified tiny signs of breast cancer in 11 women, which had been missed by human doctors. Now, this is not to be the fault of a doctor. This is exactly why we want artificial intelligence helping people. And there's even an article here, or I'm sorry, a image of a woman, Barbara, that had her tumor caught early by artificial intelligence. Now, again, I mentioned computer vision very briefly. How is it done? Well, images within them are comprised of pixels. And when you develop an artificial intelligence model, what it is it's taking anything and turning it into data that can then be actionable within the model. So like a GPT, for example, changes all the words that are inputted into it and turns it into data. And it's created in some sort of like vertice. And there's a lot of relationship mapping between how words are connected, how they fill in the gaps to develop and output some sort of generated sentence that we as humans are used to reading. And a very similar images within all their pixels are interpreted into data, which pixels are data. You ever see like that 0 through 255 when you're looking at different colors on a spectrum and you're mixing them and you're saying this much of it's going to be the primary colors and that outputs the different colors. That's pretty much what's doing on here, happening here. And I pulled up a project I have, which is a COVID detection project. And this is what it is. It's computer vision. And it's also what's called supervised learning. In artificial intelligence, there's supervised and unsupervised. In the supervised model, we actually train these models with known outputs. So in this instance, you'll see here that there's a number of images between healthy patients, patients with pneumonia, and patients that we know have COVID. And we're going to test or use those to train the model and test against it. And what's incredible is all of it breaks down into the data points, and then you'll see the difference between normal viral pneumonia and COVID. And if I scroll down here, you'll see how the model is testing. So there's a matrix here that shows that 105 cases were identified where they actually had COVID or didn't have COVID, and it was the actual right value versus those who had COVID but actually didn't have COVID. And that's what I meant earlier. Like these are just probability and statistics. With what certain probability do we think it deserves another look? And if we go back to this BBC article, it does state that radiologists would revisit when there was a detection with their human eye to validate exactly what's being outputted with the different models. And you then are able to see, if I go here to the model testing aspect, model deployments, we should see somewhere, okay, that's constantly looking at how it performs over time. Should have, my model training, here it is, right here. So as you run and test the model and it becomes smarter and smarter, you can actually see the accuracy continue to increase. Here, value loss versus the value accuracy, 22%. And by the end, you're starting to get towards 80% accuracy with properly identifying the right cases. In this instance, this model was created to use x-rays, just like these mammograms are, and properly identify COVID patients. Now, my projects in artificial intelligence, using computer vision, is a very elementary version, from what I've seen of this program called Maya by Kieran Medical Technology, and it stands for Mammography Intelligent Assessment, and it's their breakthrough AI platform for breast screening. And what I did was uncover the patented technology, and they do talk about the use of computer vision here, but it's that next level. Like someone within the medical field wouldn't be able to take something like computer vision and patent it because it's already in existence. It's a known thing. And when you're going after a patent, it's got to be novel, new, and useful. And what I do is just read the first claim to understand really what I'm getting myself into with what this technology is. So it is, and bear with me, if you've never read a patent, the language, I don't know who came up with this. I've actually got a book down behind me about patent drafting and the art of it. And this is why you pay patent attorneys exorbitant amount of money. Just when I was doing it, just ended up not being for me. I would get these these clients come in with their fascinating business ideas, and then they would leave, and I'd be like, I kind of want to see how that thing turns out. And that's where I'm at in my career now, where I just want to get to that next level. Anyway, back to this patent. A computer-aided method of analyzing mammographic images, the method comprising receiving a mammographic image, segmenting one or more anatomical regions of the mammographic image. So that's something. If we go back here to the article and see the image, I'm assuming that there's different densities of tissues where the machine learning algorithm would have, or the computer vision would have to understand, it looks different within this segment of the breast tissue versus this other segment. And that's kind of this added value. Going further back into the patent, identifying a tissue type, there we go, and a density category classification of an anatomical region, and using the identified tissue type and density category classifications to generate classifications output for the mammographic image. So again, what it's saying is that really this model, the additional added value, the new novel concept, is taking this image, segmenting it into different areas, running kind of like smaller simulations within each, because the tissue is going to be different, probably maybe even the equipment they use. I'm not versed in mammogram technology, and because you would need to know that the image being used is consistent with how the models are trained, and then with the segmentation, identify here, the different characteristics of if it's going to be classified as potential cancerous tissue, it would be different here than it would be in these circled regions. And that's incredibly fascinating. It's not just GPTs with artificial intelligence models. The stuff they're doing in healthcare to save patients is amazing. I mean, how many people in the past potentially could have had their life saved through having that next set of eyes through this sort of model? And I think that's where we just, AI's taking jobs, doing this, doing that. It's not taking radiologists' jobs in this instance. They still need to have that domain business knowledge. And that is one aspect of creating and utilizing these models that is very important, is that they're not perfect. Again, artificial intelligence models use historical data to give outputs, and they still need that person with the expertise to validate, at least at this point, what is being outputted by these machine learning models, because it is not with 100% confidence that a lot of these models are being utilized with. What we do if you're creating some sort of model is understand different evaluation metrics, whether it's like precision, accuracy, F1 score, recall, and within those are different mathematical characteristics of what is valued and what is more important. So then you create the model to be the best it can be in that specific evaluation metric, sacrificing the other things, and you're just not going to get to 100%. There's some models where you're getting at like 75%, and that's pretty damn good, surprisingly. So you still need that external validation, but people miss things, and it's good to create something and have a tool like Maya to give that second look and save lives.